If you're building a garage or shop and you only rough in 2 outlets and 1 light, you're going to regret it. Maybe not the day it's finished, but 2 years later, when you want a welder, EV charger, compressor, lift, cameras, better lighting, or a clean setup that actually feels like a dream shop, every missed rough-in gets harder, uglier, and more expensive to add. It's not just about having a building with power. The dream is walking in, hitting one switch, the whole shop lights up, the car's on the lift, tools are charged, TV's on, Wi-Fi works, and there's no extension cords dragged across the floor. That's what we're planning for. So let's walk through what I'd rough in as an electrician if I was building my dream garage or shop. Not just the bare minimum code, what I'd actually want when it's done. Imagine a detached garage or shop. The question isn't what's minimum. The question is, what am I gonna wish I'd roughed in 5 years from now? First, the subpanel, the boring part that makes the dream possible. If this is just a basic attached garage, maybe you don't need one. A lot depends on where your main panel is and what you're actually doing in the garage. But if it's a detached shop or you're planning a welder, compressor, heater, EV charger, RV power, or future expansion, I'd strongly consider a subpanel. Instead of dragging every circuit all the way back to your main panel, now you've got a local hub for the shop. That's the difference between a garage that feels cobbled together and a shop that feels planned. Maybe a smaller garage gets something like a 60 amp subpanel. A larger shop with heat, EV charging, a welder, compressor, RV power might need more. I'm not saying every shop needs a 125 amp subpanel. I'm saying don't size it like you're only ever going to run 1 light and your phone charger. Think about the loads before you choose the feeder, and don't just slap the panel anywhere. Think about shelves, toolboxes, freezers, workbench, the equipment layout. Now for a typical panel, think at least 30 inches wide, 3 feet deep, and 6.5 feet high, clear working space. Your panel's not a pegboard, it's not a storage shelf, and it's not supposed to be buried behind junk. If it's detached, you're also thinking about feeder sizing, disconnect, trenching, conduit, grounding, and neutral ground separation. At the main service, neutral and ground are bonded at one point. If it's a feeder supplied subpanel, neutral and ground stay isolated. Don't guess on that one. Now, receptacles. This is where most garages get underbuilt. Code minimum might be 1 GFCI protected receptacle outlet in each vehicle bay, fed by a required 120 volt, 20 amp garage receptacle circuit. On a 20 amp circuit, you can often use 15 amp duplex receptacles if the circuit feeds more than 1 receptacle. But that's minimum. And minimum is not our dream shop design. 2 outlets sounds fine until you start using your space. Then suddenly you have a battery charger, shop vac, work light, pressure washer, freezer, and utility equipment fighting for capacity with extension cords everywhere. That's not a dream shop, that's a pain in the rear. Nothing ruins a beautiful shop faster than orange cords running across the floor like a temporary job site. So break your garage into zones. Parking bays, workbench areas, tool storage, freezer or fridge spot, garage door openers, utility equipment, exterior walls, and future equipment. I'd want outlets along every usable wall. Plenty around the workbench, outlets near the vehicle bays, and ceiling outlets where they make sense. I'd also want exterior receptacles. And I wouldn't run the whole dream on one 20 amp circuit. I'd plan multiple 20 amp receptacle circuits, especially around the workbench, tool areas, so the freezer, charger, tools, and shop vac aren't all fighting each other. Depending on the structure, you might use NMB in finished walls, EMT in exposed shop areas, PVC where appropriate, or another wiring method. But exposed work areas get beat up. So I like wiring methods that are clean and protected. And don't only think low on the wall. Higher outlets are great around workbenches, soffit outlets are useful, and outlets around 3 feet high can be really convenient for shop vacs and chargers because you can still store things underneath them and you don't have to bend over every time. The goal is simple, no permanent extension cord lifestyle. And if you want the cleanest look, plan a utility room or utility corner for the panel, security cabinet, router, camera equipment, boiler, and anything else you don't want to stare at. Plan the walls, floor conduits, and equipment around that. Now let's talk 240 volt rough-ins. This is where planning ahead can save serious money. Even if you don't own the equipment today, think about the path now. EV charger, welder, bandsaw, mini split. These are usually dedicated circuit conversations. A larger compressor may be 240 volts on its own circuit. A mini split usually gets its own circuit to an outdoor disconnect sized from the equipment nameplate. A heater can be a serious load. An EV charger might be 40 amp circuit for a 32 amp charger or 60 amp circuit for a 48 amp charger, depending on the charger and the setup. That's why you plan this before the walls get finished. A welder plug on the wrong wall is almost as annoying as no welder plug. Your $10,000 miller doesn't want to suck power through a 100-foot extension cord. A compressor beside your relaxing corner might drive you insane, and an EV charger is much easier to plan before the garage is finished. Painted, shelved, and packed full of stuff. You don't have to buy every toy today, just make sure your shop is ready for the toys later. And if you ever sell the place, those clean rough ends become good selling points. Now, if I was building my dream shop, I'd plan for a 2-post or a 4-post lift early. That's not something that you want to figure out after the floor is poured and you find out you don't have the slab, ceiling height, or layout. A lift turns a garage into a dream shop fast, but it changes the layout because now the work is happening above you, below you, and around the vehicle. Most conventional 2-post lifts need power at the lift's power unit or motor controller. A lot are 240 volt single phase, some are 120, and the exact circuit size comes from the actual lift manual. So I'd plan the lift location and conduit path to the lift leg where the power connection will be. Don't just hope there's a plug nearby. I'd also want receptacles near the lift, air near the lift, and serious lighting around the lift, because moving a lift circuit later is not fun. Now, if you're planning a compressor, don't just think about the electrical circuit. Think about where it should live. Do you want to hear it? No. The motor nameplate matters. Some compressors are 120 volt, some are 240. Some are 20 amp, some are 30 amp, and larger ones may need more. Same with woodworking tools and dust collection. A table saw, planer, jointer, or dust collector may need its own 120 volt or 240 circuit, and you may want a control location or low voltage control wiring. You don't need to design the whole air system today, but at least think about where the equipment should live, how it gets its power, and whether you need a future path for controls or wiring. That's how you keep the shop clean instead of turning every future upgrade into a workaround. Now let's talk comfort, because the dream shop isn't much of a dream if it's freezing in the winter, roasting in the summer, or full of fumes. Think about heat, air conditioning, mini split, ceiling fans in every bay, and maybe an exhaust fan if you're welding, working on vehicles, dealing with fumes, or just moving out hot air. Electrically, these are not afterthoughts. A mini split usually needs its dedicated circuit to an outdoor disconnect sized from the MCA and max fuse, or breaker rating on the unit nameplate. An electric unit heater can be a large 240 volt load. Ceiling fans still need proper boxes and switching. An exhaust fan might need a switch, speed control, timer, thermostat, or interlock depending on what you're doing. Imagine the doors are closed, it's raining outside, truck's in the bay, lift is ready, and the TV's on, and the shop is comfortable. That's what we're roughing in for. Now, lighting is what makes your shop feel expensive. You can have a nice floor, nice cabinets, nice truck, and lift, but with bad lighting, the whole place feels cheap. A garage should not feel like a cave with one bulb in the middle. For lighting circuits, a small garage may be fine on a 15 amp lighting circuit with 14.2, or you may want 20 amp lighting circuits with 12.2, depending on the setup. And if the lights are going to be on for 3 hours or more, treat them as a continuous load and size that circuit accordingly. With LED lighting, the wattage is usually lower than in the olden days, but a big shop may still need multiple lighting circuits, exterior lights, contactor controls, or zones. For a nice bright 24 by 24 garage, I'd be thinking roughly 30 to 40,000 lumens. That could mean 6 to 8 4-foot LED shop lights or wraparound fixtures at 5,000 lumens each. For 30 to 40 foot shop, I'd be thinking 50-foot candles, and you're around 60,000 lumens. At 75-foot candles, you're around 90,000 lumens. So now you're thinking high output linear fixtures or LED high bays. I'd put the lights on switched zones, main shop lights, workbench lighting, individual bays, extra lift bay lighting, wall lighting, exterior lighting, maybe lounge corner pot lights on a dimmer, and maybe motion sensors, smart controls, or a lighting contactor if you have multiple lighting circuits. Not every garage needs a contactor, but in a bigger shop, that can make sense. When you open that door at night, the whole shop should light up like a showroom. That feeling matters. My next shop will have lighting in the floor, shooting at the underside of the car. Now that's not code minimum, that's dream shop stuff. But it needs proper fixtures rated for the location, sealed against dust, water, and oil, flush with the floor, protected from tires and lift arms, and switched separately. Floor lights don't replace good work lighting. They're a bonus, but picture the car on the lift with the light coming up underneath it. That's the kind of detail that makes a shop feel like yours. Plan one outlet per garage door opener. Garage door opener receptacles can usually be on the garage receptacle circuits, but they don't count as the required bay receptacles. And yes, they still need to be GFCI protected. Personally, I like the idea of putting them on their own circuit or switch, so you can shut them off when you leave for vacation. I'd also think about ceiling outlets for retractable cord reels, ceiling mounted air cleaners, battery chargers, or future equipment. If it's just a door opener, that's one thing. If it's a cord reel or equipment, think about the actual load. Look up before finishing. The ceiling is part of the electrical plan too. Nobody wants to crawl through the blown-in insulation later because they forgot a ceiling outlet. Now outside the shop, I'd rough in floodlights, lights above the garage doors, lights near the man doors, and exterior receptacles. Driveway side, yard side, back of the shop, maybe soffit outlets for holiday lights. Exterior receptacles should be weather resistant, GFCI protected, and have the proper in-use covers where required. For lighting, think motion sensors, photocells, switching, and controls. If you hear something at night and want to turn on the shop lights from the house, that's possible, but only if you plan it. I'd also think about RV or trailer power, maybe a 30 amp RV receptacle or 50 amp. Put them on the right dedicated circuit, wire size, breaker, receptacle, and location. Then I'd add spare conduits. If the trench or walls are open, run a 2-inch PVC sleeve outside for a future junction box point. Maybe someday you want power to a greenhouse, woodshed, gate, well pump, chicken coop, fuel tanks, whatever. A spare conduit saves you from drilling through your finished shop later. That's cheap insurance. And don't throw power and data in the same conduit just because it's convenient. Now, cameras, internet, speakers, and security. This is one people skip and then regret. If the walls are open, run Cat 6 anywhere you might want a camera. Driveway, overhead doors, man doors, inside the shop, around back. Bring those to a low voltage area or network cabinet. Think about Ethernet, Wi-Fi access point, TV location, alarm keypad, door contacts, overhead door contacts, motion sensors, horns, or sirens. If it's a steel shop, Wi-Fi matters even more. Steel and Wi-Fi don't mix. So plan for a wired access point instead of hoping the house router reaches. For speakers, I'd rough in proper in-wall rated speaker wire. A simple setup could be 16.4 from the amp to a volume control, then 16.2 from the volume control to each speaker. Maybe 2 speakers inside and 2 outside, each on their own volume control. Keep low voltage separate from power. Proper boxes, proper paths, service loops where they make sense, and label the cables. You're sitting in the chair, TV's on, car's on the lift, doors are closed, camera and internet all work. That's not an accident, that's planning. Now, if I'm building my dream shop, I'm roughing in a relaxing corner. People might laugh at this until they have it. A TV on the wall, outlet behind the TV, Ethernet behind it, outlet by the recliner, maybe pot lights or dimmed lighting, a fridge, maybe conduit from the TV to a cabinet so there aren't cords all over the wall. Because I don't want to just work in the shop, I want to enjoy it. A shop should be useful, but it should also feel like yours. Then we can consider generator or backup power. Not every garage needs a generator inlet, but if this shop might become part of your backup power setup someday, think about that now. Where would the generator sit? How would it be wired? Would you use an interlock, automatic transfer switch, or critical loads panel? A lot of portable generator setups are 30 or 50 amps, but the safest setup depends on the generator inlet, transfer equipment, wiring, and what loads you're trying to run. Don't guess. Plan it properly before everything's finished. Do not backfeed through a dryer outlet. Do not use a suicide cord. If the power goes out, you don't want your dream shop turning into a dark shed with a nice floor. We want to get that brake job done. Take pictures before it's finished, before insulation, drywall or steel, or the finished panels. Take all the pictures. Every wall, every ceiling, every box, every conduit, everything in the floor before concrete. Those are gold later when you're trying to mount cabinets, adding shelves, troubleshooting, or trying to remember where everything went. Someday you'll be standing there with a shelf, a drill, and a bad memory. Take the pictures and label what you can. Panels, breakers, conduits, low voltage cables, spare pipes. You will not remember as much as you think. So here's the bottom line. The code minimum might pass inspection, but you're not dreaming about a code minimum garage. You're dreaming about a shop that feels finished. Bright lights, clean walls, no ugly cords, and power where you need it. A lift that's ready, tools charged, cameras working, internet that doesn't cut out, a TV corner where you can sit down and enjoy the place. That doesn't happen by accident. It happens because you thought the electrical through before the walls were closed. You don't have to install everything today. But before it's done, you have to think it through, because the cheapest time to rough it in is right now. After that, everything gets harder, uglier, and more expensive. So drop a comment. What's the one thing you'd want roughed into your dream shop? And if you're planning a shop and need help thinking through the electrical or code questions before anything gets closed up, visit electrohelp.com. There are consultation options where you can send plans, photos, or a quick walkthrough video, and we'll help you efficiently design the electrical in your dream shop before it gets expensive. We're always working towards the gold standard of electrical advice. If you like our content, subscribe to the channel, and thanks for watching.